Hi guys! For today, we are going to conduct simple experiments which you can also do on your own in order to understand the nature of matter and its measurement. Join our team as we venture in measuring, classifying, and understanding the changes a matter undergoes as it is exposed to different variables.
As you can see, we have two solid geometric shapes, namely a cube and a sphere. Using our ruler, we were able to measure its dimension and tabulate the data, as you can see in Table 1.1. Given the instructions for data analysis, we were able to convert the measured rectangle length and the sphere's diameter to hectometers, stating our answers in scientific notation. We were also able to calculate the areas of our rectangle and circle in centimeters squared with the correct number of significant figures by adding one uncertainty for each variable.
For part B, experiment 1, we were able to calculate the mass of sugar by simply subtracting the initial mass of the container to its final mass where the sugar was added. We were also able to convert the mass to decagrams and pounds accordingly, stating our answers in scientific notation.
Starting this segment, we highly recommend using actual graduated cylinder for accuracy of data and future experiments. But due to financial constraints, we are going to use the source container, which has a fairly decent accuracy of up to 10 milliliters. Using paperweight and a rock sample, we are able to calculate its volume by subtracting the initial volume the water occupies in the container. The final volume the water and sample occupies in cubic centimeter while following the correct number of significant figures.
Given the mass of cylinder with water, volume of water, we were able to calculate the density of water by subtracting the mass of cylinder with the mass of both cylinder and water, and dividing the answer to the volume occupied by water. Our answer is close to 1 gram per ml with little to no margin of error and still following the correct number of significant figures.
For this experiment, we took advantage of aluminum's malleability and made our own metal ball and made it as dense as we can for accuracy of data. We then measured its mass and volume by doing the same procedure in previous experiments. After gathering data as shown in Table 5.1, we were able to solve for the metal's density by dividing its mass to unit volume it occupies. For the second part of this experiment, we used a tin foil of the same metal used in the previous experiment and cut it in a square with little to no margin of error.
We then quantified its data as shown in Table 5.2 by measuring its mass, length, and width. With this data, as well as the density of aluminum in the previous table, we were able to calculate for the aluminum's thickness, which is 0.014 centimeters, and tabulate our answer in scientific notation. In order to classify matter, we need to understand the nature of elements, compounds, and mixtures. For this experiment, we prepared 9 dishes of different materials. For dish 1, we have 4 washers, dish 2, 4 bolts, Dish 3, 4 nuts. Dish 4, 4 sets of 1 nut and a bolt. Dish 5, 4 sets of 2 nuts and a bolt. Dish 6, 4 sets of 1 nut, 1 washer, and a bolt. For dish 7, 1 washer, 1 nut, and 1 compound as in dish 5, and 1 compound as in dish 6. For dish 8, we have 2 washers, 1 nut, and 2 bolts. For dish 9, 1 compound is as in dish 4, and 2 compounds as in dish 5. We then categorize the materials in each dish as element, homogeneous mixture, heterogeneous mixture, or compound, and recorded our data in Table A. We then place the examples of elements, compounds, and mixtures on another table called Table B and labeled them, as well as the compounds with their specific chemical formula.
For this experiment, we put 2 ice cubes in a Ziploc bag and find its mass before it melts. The mass shouldn't change because mass is conserved in nature. Changing the state of water doesn't change its mass. Its previous mass and mass after melting is still the same. For this experiment, we can see the conservation of mass present as we cut a cardboard into 10 pieces. Mass is conserved in nature. Changing the arrangement of parts during a physical change does not change its mass. For this experiment, we have a salt and water, separated and weighted to find the mass. We then mix the both to see if dissolving salt will alter the mass of the final solution. It turns out that the mass should not change because it is conserved. For this semifinal experiment, we want to see if chemical reaction alters the mass of our sample. We first measured the mass of container with water and an Alka-Seltzer. We then mixed both in the same container and found out that in this reaction, we form a new substance, carbon dioxide gas, which is a chemical change. Mass is also conserved in chemical changes as long as the mass was kept intact in a container. In our case, not sealing the bag will cause some of our matter to escape. The form of carbon dioxide gas, which will affect the amount of gas present in the sample.
For this experiment, we're going to observe a physical change in the properties of water. First, place a few drops of water on a piece of wax paper. Notice its rounded appearance. Touch a toothpick to the drop of water. Nothing should happen. Second, dip the toothpick in a container of soapy water and touch the drop of water again. Observe what happens. The bubble should collapse because soap will interfere with the cohesiveness of water and breaks it up. This is a physical change because the molecule of water didn't change, just its behavior did. Fill a petri dish about half full with water. Sprinkle a thin layer of pepper on the water. The pepper will float on the water because the surface tension of water holds it up. Then, use a clean toothpick and touch the water. Notice that nothing happens. Lastly, dip the toothpick in a container of soapy water and then touch the water again. Observe that the pepper instantly spreads to the edges of the dish. The soap rolled across the top of the water and pushed the pepper to the edges. This is a physical change on the surface of the water that propelled the pepper to the side.
And that's it, we're done for this day. I hope this video allowed you to gain deeper intuitive understanding about the matter because it is a fundamental aspect in both physics and chemistry. This is Group 1, now signing off.